Welcome back to my chemistry lessons. Today we are going to discuss an important property of carbon atom. It is called catenation. Catenation is a self-linking property of carbon atom with another carbon atom, and then carbon can form long chain compounds, carbon-carbon bonds, CC bonds, and at the same time carbon can also form closed type compounds. So this important property of carbon atom makes carbon most popular in the periodic table. So result of that, carbon can form a variety of compounds in the universe. So let's see how we can explain the catenation of carbon atom. So let's see what is catenation. Catenation is a self-linking property of a carbon atom. So carbon can form carbon-carbon chains. The catenation and the carbon's unique small size makes carbon most popular in the universe. So let's see how can carbon forms carbon-carbon bonds. So the electronic configuration of carbon atom is 1s2, 2s2, 2p2 because carbon has atomic number 6. That means carbon contains 6 electrons and 6 protons. So when we write the ground state electronic configuration of carbon atom, we can write like this: C6, 1s2, 2s2, 2p2. So when we write excited state electronic configuration, so I'm not changing the first part, 1s2, that's a K shell, and L shell contains 2s and 2p orbitals. So I'm just writing box model. So this is a 2s, and the p orbital, according to magnetic momentum quantum number, p orbital can directed into 3 directions of x and y z axis. So the p orbital has dumbbell shape. So this is x axis and this is y and z. So one p orbital directed along x axis called px, and if the p orbital directed into y, so z direction is called pz, and if along y axis called py. So that's why we are writing a p orbital into 3 orientation forms. That means px, 2px, 2py, 2pz. That means p orbital along the x-axis, p orbital along the y-axis, p orbital along the z-axis. So here what happened in the excited state, the one of the s electron jumped into p orbital, so 2p becomes 2p3. So the one electron from 2s orbital jumped into 2pz orbital. So this becomes 2s1, and the remaining 2p electrons we can fill like this. So literally now at outermost orbital of carbon has 4 electrons. These 4 electrons are ready for combining with the other atoms, and the carbon can form stable octet root completer or inert gas configuration attained compounds, stable compounds. That's why these 4 electrons of carbon atoms are ready to combine with the other atoms. So the 4 electrons present in the outermost orbital of the carbon atom can be represented like that, 4 lines around the carbon. So that means carbon has 4 valencies. So carbon can combine with 4 other atoms. So due to this property, catenation, carbon can form open chain compounds, CCC linear compounds, and closed or cyclic chain compounds. So here, if you see this CCC chain, the first carbon has valency 4. So there are 3 valencies here, one utilized for combine with other carbon atom, and the second carbon atom used one of its valency to combine with the third carbon atom, and third carbon atom used to combine with other carbon atoms. So that chain is goes like a linear chain, and in another case it forms a cyclic compound. So due to the catenation, carbon can form open chain compounds and closed chain compounds. In open chain compounds, the important hydrocarbons are alkanes, alkenes, alkynes. Alkanes means there is only carbon-carbon sigma bond or carbon-carbon single bond containing hydrocarbons, and if it contains carbon-carbon double bonds, it's called alkenes. Alkenes, E and E, alkene. In alkane sigma bond compounds, ANE, the suffix is called suffix. So the first part is known as a prefix, and the second part is known as a suffix. So ALK ANE. So here ALK ENE, that means a double bond carbon-carbon double bond compounds. And third type of hydrocarbons are alkyne. There is a triple bond containing compounds. These group of compounds we will discuss later stage in detail. So in closed chain compounds we have aliphatic and aromatic compounds. The best example for aliphatic compound is a cyclohexane. The cyclo means a ring type and hexane means it contains 6 carbon atoms. And there is another one, benzene, C6H6, that contains alternative single bond and double bonds. So if it is a sigma bond here, next one will be double bond, next sigma bond, then double bond, and this one will be double bond. So in benzene, the carbon-carbon bond is alternative single, double, single, double, single, double bonds. So these all will discuss later stage. So here in the case of cyclohexane, if you see the first carbon atom, the carbon has 4 valency. The 2 valencies are utilized to form one bond here, one bond here. So 2 valencies utilized to form carbon-carbon chain, and the rest of the 2 valencies are combined with the 2 hydrogen atom and form CH2. So in cyclohexane, each carbon has 2 hydrogen atoms. In benzene, each carbon atom has a 1 hydrogen because rest of the 3 valencies are utilized for carbon-carbon sigma bonds and pi bonds.